Next, let us look at a tough question from Pathfinder, and we'll be solving it in a single step. And with the beautiful visuals which I'm giving you, you can understand it instantly. So basically, there are two charges on an inclined plane, and this charge is fixed here. Okay, and this charge, we can move on the incline. The question that is asking is what is the maximum angle beta so that this charge is at rest. The charge B is at rest. Okay. Also, I have added another part to this question. That is, for this case, for the maximum beta case, what is the distance or distances between the charges, or the range of distances between the charges when beta is maximum? So first, let us look at the forces on this charge. See, this is anyways at rest. We are studying the forces on this. So on this charge, there is a gravitation force downward. The component of gravitation force mg sine alpha is this. Okay, we have mg cos alpha and normal in this direction, perpendicular to the inclined plane. Next, this is the electrostatic force between the charges. Okay, and this is the friction force. So just remember, the white is the gravitation, blue is the electrostatic, and red is the friction force. Next, for a given angle beta naught, so I'm drawing the inclined plane so that you're seeing it normally like this. Okay, now for a given angle beta naught, let us just analyze these forces. Okay, what will happen if we move the charge like this? How far can we move the charge? How near can we move the charge? Okay, so just let us see this. See, the gravitation force is constant in direction and in magnitude always. Okay, next, we have this is the electrostatic force. Okay, this electrostatic force will be here, but I'm completing the triangle here. Okay, of these three forces. If we can complete the triangle of these forces, then this particle will be in equilibrium. If we cannot complete the triangle, then this particle will not be in equilibrium. So we are seeing different cases where the particle will be in equilibrium. So now see this force. This one we have seen gravitation, which is constant in magnitude and in direction. As we move near, the electrostatic force increases. The length of that vector increases. Okay. See, moving near, this length increases, but the direction is along this line. Okay. Next, you see, this is friction. Friction adjusts such that this particle is in equilibrium. Okay. So you're seeing. So what we can see here is, see, friction can take a range of values, right? So suppose the particle is here, and if this friction is within the range, the particle will be at rest. Suppose we move the particle and still this friction is within the range, still it will be at rest. Suppose you keep moving it very far and this becomes very small, this length is not enough to complete the triangle. So again, it will not be in equilibrium if you move it after a certain distance. If we come really close, this thing will become very big. Okay, if this becomes very big, this cannot become very big, right? So that time also, if you bring it very close also, the friction cannot adjust itself such that this will be at rest. So for a given angle beta naught, there is a range of values for which if you keep this charge on the inclined plane, it will be at rest. Okay, let's move on. Next, what we'll do is, we'll not move the charge. We'll keep the charge still. We'll keep this force also still. And we'll move these vectors and analyze. Okay. So let us just see now. See, I'm keeping a constant force. Okay. And I'm just rotating this constant force and seeing what could be the maximum beta. Or where will this maximum beta occur. Okay. So see, if I'm rotating it, initially beta is increasing. And then again you see that beta is decreasing. We know that this electrostatic force varies in both direction and magnitude depending on the distance between the charges. Okay. So what I want you to notice here is, you see here, just see this. See, the beta is maximum here and again beta becomes minimum. Again maximum and again it is becoming less. Okay. So there is one point here where beta has become maximum. Okay. And at that point, we can say that this friction is perpendicular to the electrostatic force. Okay, if this comes still this side, this the angle will decrease. If it goes still that side, again the angle will decrease. So exactly when it is perpendicular, when the angle between the friction and the electrostatic force is perpendicular, this beta will be maximum. Okay, we have taken for some value of friction. Okay, that means beta max will have occur for the maximum value of friction, right? So what is the friction maximum value? Mu mg cos alpha. Okay, and what is this? Mg sin alpha. So he has asked us to find what is the beta maximum. So what can we write? Tell me. So I can write here sin beta max equal to mu mg cos alpha divided by mg sin alpha. So I can write this beta max equal to, we can cancel out these both, so we'll get sin inverse mu cot alpha. Okay, so this is the value of the maximum angle which you can move this charge from the fixed charge. Okay, we also asked another question: what is the distance between this charge and the other charge at this instant? Okay, so what is the force? Tell me. If the distance is d, this will be k q square by d square. Suppose both have same charge. Okay, now see, we said that for a given angle there are a range of values for which this will be at rest. Okay, now we are saying that this vector is friction maximum. If suppose I rotate it, if this for this given angle, if this is extended even further, this length will increase even more. Can friction go above a certain maximum value? It cannot go. So that means we cannot go this side. If I come this side, again the length of this vector has to become more. So it will become more than the friction max. So there is a unique value of distance where this charge will be at rest at this beta max. Okay, and yes, we can find out what is that distance directly. What can we write? Tell me. Directly, you can just write tan beta max equal to just perpendicular by base. So mu mg cos alpha divided by kq square by d square. Okay, so we know beta max here anyways. So just take d here and you can find out what is that unique value for this beta max where this particle will be at rest.